Okay, so this question often causes a few problems because of the last step, but let's go through it from the beginning. We've got a pivot here with a uniform meter ruler. So we know the length of this plank is 1 meter. And we have got a object of an unknown weight that we're going to be trying to find, resting on a pan whose weight we do know. And then we've also got a 2.5 Newton weight on the other side. And so what we're basically doing is we're going to be using moments. So we're trying to find out what is the weight of this unknown object here. And we'll call this unknown object X. And we'll say that that has a weight that we do not know. We'll call that X newtons, acting at a distance 15 centimeters away from the pivot point. Now, where a lot of students fall down on this is forgetting to include the weight of the ruler. So we know that the weight of the ruler, given that it's uniform, is going to be acting in the center of the ruler, and that is going to be acting downwards. We know that the weight there is 1.5 newtons, and since the ruler is a meter long, that's going to be occurring at the 50 centimeter mark from this left side edge. Now we know that the pivot is 15 centimeters from that left side, so the distance between the pivot and the weight of the ruler is going to be 50 minus 15, which equals 35 centimeters. And then we also have our 2.5 newtons acting at a distance 60 centimeters from the pivot. So to find out what the weight of the unknown object is, we need to calculate our moments. Okay, we know, since this is in equilibrium, that our clockwise moments will equal anti-clockwise. So if we look at our clockwise moments, that is anything going in that direction there, we just have to add these together. Clockwise moment due to the weight of the ruler is going to be 1.5 times 35 centimeters. You can put that into meters as well, but it doesn't actually matter as long as you're keeping the same unit all the way through. Plus the moment due to our 2.5 Newton weight. That's our 2.5 times 60 centimeters. And so that gives us a clockwise moment of 202.5 Newton centimeters in this case here. So that there is our clockwise. Now our anti-clockwise has got to be equal to that, but it's also equal to our unknown object plus the weight of the pan multiplied by the distance from the pivot. And that's where people usually fall down on this. They forget that we've got this weight of the pan as well. Now we're told that the pan has a weight of 0.5 newtons, so we'll need to remember that at the end. So our unknown weight plus the weight of the pan times 15 has got to be equal to my clockwise moment of 202.5. So the weight of X plus my pan is 202.5 over 15. That gives us 13.5 newtons. But then we need to remember, big exclamation mark, we need to subtract the weight of the pan. So therefore, the weight of my unknown object is 13.5 newtons minus the 0.5 newton weight of the pan, which gives us 13 newtons. And that is answer C.